Hello everyone. Today we are covering a topic from IGCSE Cambridge Physics, lesson Motion Forces and Energy, topic Physical Quantities and Measurement Techniques, subtopics Scalars and Vectors. Physical quantities can be classified into two categories, scalars and vectors. A scalar quantity has magnitude only and has no direction in space. For example, mass, energy, time, temperature, speed, distance. Now, for all of these quantities, when you're saying it out loud or telling it to someone, it doesn't make sense to include a direction. For example, if I say, my mass is 50 kilograms to the north, does that make any sense to you? No, right? So a scalar has no direction. Doesn't make sense for us to say a scale, represent a scalar with a direction. It has only a magnitude and no direction. Unlike a scalar, vectors have both magnitude and direction. For example, force, acceleration, weight, and velocity. Now, think of an instance where there is a certain object, and I tell you there is a 5 Newton force acting on this object. How would you draw it? You might think of drawing it like this, but someone else would think it's like this, or even like this, or this. How would you know which one I'm talking about? Because all of these forces do different things, right? So it's important to know which one it is. Now, I'm saying there is a 5 Newton force acting on this object from the top to the bottom. Now that I mentioned the direction, it is very clear that I am talking about this force, this 5 Newtons. Now, do you understand how important it is to mention the direction of a vector quantity? Vectors are represented by straight line arrows. The length of the arrow is proportional to the magnitude of the vector, and the direction of the arrow or the arrowhead is pointing at the direction of the vector quantity. Very often, we have to find the resultant force where two forces are acting on a certain object. To do this, we can use two methods. The triangle method, also known as the head-to-tail method, or the parallelogram method. For the triangle method, say there are two forces, V and U, acting on the same point. V with a magnitude of 6 newtons, and the angle to the horizontal is 20 degrees. And then there is U with a magnitude of 5 newtons, and the angle to the horizontal is 80 degrees. This is the case, we need to draw these two arrows such that the head and the tail of both arrows together. So we place the vectors with the head of the previous vector, in this case U, connected to the tail of the next vector, which is V. And then we connect the tail of the first vector to the head of the second vector with this green arrow shown here. And this is your resultant force. This force shows the magnitude of your resultant force, and the direction of the arrow shows the direction of the resultant force. If your original forces are in the clockwise direction, in this case it is going in the clockwise direction, the resultant force is going to the anti-clockwise direction. So the head of the resultant force has to meet the head of the previous force. And if you measure this angle, you can get the angle of the resultant force to the horizontal. To get the magnitude, you should draw this diagram into scale. So in this case, since V is 6 newtons, you can represent V by a 6 centimeter line. So 1 Newton is represented by 1 centimeter. Then what is the length of U? It is 5 centimeters. Now you can simply use a ruler to measure the length of this green line to find the magnitude of the resultant force. Very similar to this method, we have another method called the parallelogram method. Here, you have to place both vectors u and v at the same initial point. They start at the same point, but you have to draw it to scale and you have to be mindful of these angles. So in this case, this angle would be 80, this would be 20. And once you do that, you have to draw a parallelogram with these two lines. One line that is perpendicular to V, another line that is perpendicular to U. And once a parallelogram is formed, you have to draw the diagonal of the parallelogram starting from that same starting point, and that diagonal will represent your resultant force. The arrowhead for that diagonal has to be away from the initial point, and if you measure the magnitude of this, measure the length of this resultant line, you will get the magnitude of the resultant force. To get that, you have to draw this diagram to scale, V being 6 centimeters and U being 5 centimeters. Let me once again very quickly go over the steps for the triangle method. You choose the scale, draw the first force, and draw your second force also to scale. But the most important thing is the head has to meet the tail of the second force, just like this. You can draw this, you can have a start like this if you're going to do the parallelogram method. In that case, you need to complete the parallelogram like this. But if you're using the triangle method, then you need to draw the two forces like this, where the head meets the tail. And finally, if it's a parallelogram, you draw the diagonal. If it's a triangle, you complete the triangle. Now, you can measure the length of the resultant force. And then this can be converted into newtons using your scale. A very common scenario that we will come across is to find the resultant of two perpendicular forces acting on the same point. One horizontal force and one vertical exactly perpendicular to the previous force. In this case, we can find the magnitude of the force by using the Pythagoras theorem, and also the direction can be calculated using trigonometry. First, let's look at how to use the Pythagorean theorem to find the magnitude. It is actually quite easy. We use the head-to-tail method or the triangle method to draw a right angle triangle using two forces. So we draw the horizontal force first and the vertical force next, where the head of the horizontal force meets the tail of the vertical force. Then we can complete the triangle. Because the vertical and horizontal forces are perpendicular, we will get a right angle triangle. Now, to use this method, you don't really have to draw this to scale. What you need to know is the magnitude of these forces. You know, using the Pythagorean theorem, the two sides which belongs to the right angle, if you square them and add them together, this is equal to the square of the other side, the triangle. In this case, the resultant vector is always represented by the hypotenuse of the triangle. So even without drawing a diagram like this, you can simply use this formula to calculate the resultant force when you have two perpendicular forces. All you need to do is square the perpendicular forces, add them together, and find the square root to find the magnitude of the resultant force. In this example, both original forces, both the perpendicular forces are 11 newtons each. What you need to do is square 11 and the next 11, add them together, you get 242, and you find the square root to find the magnitude of R. Now that we know the magnitude, we need to know how to find this angle in order to know the exact direction of this force. We're about to find the angle in order to find the direction of the resultant force. Now, it might seem a little bit intimidating looking at all of these equations, but don't worry about it. You only need to know a very small part of it. But just so that you can understand, I'm going to go through the derivation of the equation we're going to use. So, in trigonometry, you will learn these relationships when there is a right angle triangle. So, we'll consider this right angle triangle where we need to find theta. When we define theta, the side opposite to theta is called the opposite side. The longest side is always called the hypotenuse. The longest side is always the side that is opposite to the right angle of the triangle. And the remaining one, which is exactly under theta, is called the adjacent side. So that's the hypotenuse, opposite, and the adjacent. Sine theta is opposite over the hypotenuse. That is why you have SOH in SOHCAHTOA. Right? SOH represents sine is equal to opposite, or sine theta is equal to opposite over hypotenuse. Similarly, CAH represents cos theta is equal to adjacent over hypotenuse. Finally, the TOA means tan theta is equal to opposite over adjacent. Now, these are the relationships that you would learn in mathematics that we're going to use here to derive this equation. Now, we're looking at another example where the two forces are 22.3 meters per second and 11.3 meters per second. So, we're looking at a horizontal force of 22.3 meters. Oh, in this case, it's a velocity, 22 meters per second, and a vertical velocity of 11.3 meters per second. Now, we need to represent these two velocities in terms of these sine, cos, and tan. We know we have already marked the theta. At the beginning, what we don't know is theta. Now, the reason we are going to do this is to find this theta. We'll call this Vx and we'll call this Vy. Vx is V cos theta. V here is the resultant force. V is the resultant force. And we also have Vx and Vy. So cos theta, we need to find Vx. Vx is in the adjacent side. So we go and pick an equation with adjacent in it. Now this is both opposite and adjacent. That's a bit too troublesome. So we go and choose this one. Cos theta is equal to adjacent over hypotenuse. You know, hypotenuse is V. So that is why Vx is equal to V times cos theta. Because the adjacent is equal to hypotenuse times cos theta. Similarly, we get an expression for Vy. For that, we use this first equation. Because sine theta is equal to opposite over hypotenuse, we can find the opposite is equal to hypotenuse times sine theta. That is why we have V times sine theta. Now that we have both the velocities, to find theta, we can divide these. If we divide Vx by Vy, we get V cos theta is equal to V tan theta. Cos theta, V sin theta. cos theta over sine theta is equal to tan theta. Again, another relationship you would get to know in mathematics under trigonometry. So v and v cancel off and you end up with tan theta. That's how you get tan theta is equal to vx over vy. So in a case where you know vx and vy, which is usually how the question would ask you, and you need to find theta in order to find the direction, all you have to do is apply this equation. Theta is equal to tan inverse vx over vy. Right. Now, I hope you know where to find the tan inverse function in your calculator. You have to press on shift and click on tan to get tan inverse. So just to sum up, to find the magnitude of resultant force when you have two perpendicular forces, you use the equation r squared is equal to a squared plus b squared. A and b are magnitude of the two forces. If A is the horizontal force and B is the vertical force. To find the theta, which is the angle to the horizontal, we can use tan inverse A over B. This is all you need to remember. In the previous slides, I taught you the derivation. But really what's most important is knowing these two equations. Let's use what we learned in a simple example now. There are two forces, horizontal and vertical, perpendicular to each other, acting on the same
Subscribe
point.
us now for
The
more
vertical force is
videos and
300 newtons,
content.
the horizontal force is 400 newtons. To find the resultant force, you apply r squared is equal to a squared plus b squared. A squared here is 400 squared, b squared is 300 squared. And once you simplify this, you would get r squared is equal to 250,000. And when you take the square root of that, you get 500 newtons. So the magnitude is very simple, 500 newtons. And now we'll find out the theta, or the angle to the horizontal of the resultant force. To do this, we simply apply tan inverse A over B, tan inverse B over A is equal to theta. Plus vertical force divided by the horizontal force. In this case, you will get tan is equal to theta is equal to tan inverse 300 over 400. Gives theta as 36.9 degrees. Let's look at another example, just so you can completely understand this concept. This example is to do with displacements. There's a displacement of 60 kilometers to the east and displacement of 10 kilometers to the north. We need to find the resultant displacement. The magnitude is very easy. R is equal to the square root of 6 squared plus 10 squared, which is the square root of 136. You get R as 11.66 kilometers. Now, you need to find theta to say the direction. Now, tan theta is equal to the opposite over adjacent. Opposite is 10, adjacent is 6. So, theta is equal to tan inverse 10 over 6. Once you plug it into the calculator and get the answer, you would get theta is equal to 59 degrees. We have covered the theory for this topic. Let's have a look at a past paper question. This question is asking for you to choose the answer with vector quantities. Let's look at the first answer they have given: length, mass, and time. With either of these, does it make sense to say a direction? No, right? So length, mass, time, none of these are vector quantities. Now let's look at the second one: speed, velocity, acceleration. Now, if you remember, in the vector list, we had acceleration and velocity. But speed, does speed have a direction? No, speed does not have a direction. So this set is also not the correct answer. Velocity, acceleration, and force. All three of these have directions. So, correct answer is number 3. All three physical quantities have both direction and a magnitude. So also look at answer 4. Although force and acceleration have directions, mass does not. This is why answer 4 is incorrect. I hope you have a better understanding of this topic. Thank you for listening.